session on polynomials. In this session, we will learn the different terms, theorems, examples related to the polynomials. So first, let us know what is a polynomial. A polynomial is an algebraic expression of the form f of x is equal to a n x power n plus a n minus 1 x power n minus 1 and so on a1 x power 1 plus a0 x power 0. So this is the general form of the polynomial. And if we want to know what is a polynomial in one variable, from this we can write it as ax cubed minus bx squared minus cx plus d. This is a simple example of a general form of a polynomial in one variable. Now, what are the different types? If we try to know what are the different types, simply we can say that types are again two. Depending upon the terms, we have one category. Depending upon the terms and depending upon the degree, we have another category. So depending upon the terms, if it has one term, we call it as a monomial. And if it has two terms, we know it is a binomial. And if it has three terms, we know it is a trinomial. And if it is constant or independent of x, then we call it as a constant. Example, you can take it as 4 minus 7 by 5, etc. are called as constants. And what is 0? 0 is also called as a polynomial where the degree is not defined. So these are the types of polynomials when we consider their terms. Now, if we want to consider their degree, what is the category we have? So let us see if we want to consider the degree, what are the different types we have. So the category is in that it's linear, quadratic, and cubic. What is a linear? Simple example in one variable, 3x plus 2 is an example of a linear polynomial, or you can call it as an expression in one variable. If it is a quadratic, you can take it as 3x squared plus 3x plus 2 you can take. If it is a cubic, then you can take it as 4y cubed plus 6y squared plus 2y plus 2, where the degree is, here the degree is 3, here it is 2, here it is 1. So depending upon the degree, these are the types of polynomials which we must know in this chapter. Now let us know what is meant by the zero of the polynomial. Zero of the polynomial. It is a number that satisfies the equation. So simply we can say that it is a number which satisfies the given equation. For example, if we have p of x is equal to 2x plus 1. So if we are asked to find the zeros, so we have to take this as 0. So 2x plus 1 equals to 0. So 2x is equal to minus 1 and x is minus 1 upon 2. So x is minus 1 upon 2 is the 0 of the given polynomial. And now let us focus a little on the theorems which come in this chapter. So the theorems are two basically. One is factor theorem and one is remainder theorem. What is this factor theorem? It says that if p of x is a polynomial of degree greater than or equal to 1, then x minus a is a factor of p of x. That is, x minus a is a factor of p of x. Then p of a will be equal to 0. Or we can say that if p of a is 0, or if p of a is 0, then we can say that x minus a is a factor of p of x. And what is this remainder theorem? Now let us look into the remainder theorem. The remainder theorem says that if p of x, polynomial of degree, p of x, if we take polynomial of degree greater than 1, is divided by x minus a, then p of a is the remainder. So if we get a remainder, then we can verify the division rule. That is, dividend is equal to divisor into quotient plus remainder. It can be verified, and we can solve the sums related to this remainder theorem by applying the division rule, or by taking the divisor. That means we can find the unknown term or quantity given related to the remainder theorem. So these two are the theorems basically which we'll be focusing in this chapter. One is a factor theorem and the other is a remainder theorem. So to do this better, we need to focus a little on our identities. We have learned about these identities in our previous classes. That is, you might have come across in class 7 and 8 about a little about these identities. That is, we call it as algebraic identities. So basically, what are the algebraic identities which we need to focus? X plus y whole square, x minus y whole square, x square minus y square, and x plus y plus z whole square, and x plus y whole cube, and x minus y whole cube, and x cube plus y cube is what? X cube minus y cube. And these identities are important, and if we learn these identities, the knowledge of these identities help us to do this chapter better. And these identities in detail will be discussed in the other session. Thank you.